Hello, welcome to section 2.2. What we're going to do is talk about linear functions. So throughout this lesson, what we're going to do is talk about independent and dependent quantity. We're going to fill in this table. We're going to talk about y-intercepts, input-output values. We're going to be able to use a graph to trace our input and output values, and then use equations to also do the same thing. So starting with this first one. What we're going to do is fill in this table. It says a free diver is diving from the surface of the water at a rate of 15 feet per minute. So I'll notice right away on this table I have some negative numbers, and what that means is that they're going to be below the surface of water, so that's why they're going to be negatives. So what this diver controls, we'll talk about our quantities first for independent and dependent. What this diver controls is really how long they're going to be underwater. So they control the time, which we know is going to be measured in minutes. And what I'm going to use for an expression for time, be really original and use the letter T. What depends on that? So if they're underwater for 1 minute, 2 minutes, 3 minutes, whatever it'll be, your value that depends on that is going to be their depth. And that's what's measured in feet. So notice my rate of change here is the 15, which is relating my output unit to my input unit. It relates your dependent to your independent feet per minute. And what I'm going to do with my expression for that, since it's a negative value because we're going underwater, it'll be negative 15 times however many minutes they're underwater. So let's go back to just substituting values in. If I write a function for this, I'm going to say that depth as a function of time would represent the negative 15t. So I know that if they're under there for 0 minutes, it'd be 0. If they're under there for 1 minute, they'd be 15 feet. So start filling in values. After 0 minutes, the diver is at the surface of the water. After 1 minute, they went down 15 feet. After 2 minutes, they are down to 30 feet. And then you can kind of see it's just counting by 15s after this. So my next one would be 3, and then after that would be 4. A way that we can really check this work to fill in these 3 and 4, it's a lot easier for these two because what you're doing is taking the values for 1 and 2 and you're substituting them in for t. But what we can do is actually take these values and substitute them in for the output value. So if I wanted to know how many minutes the diver was underwater before they reached 45 feet, what you could do is take that 45 and substitute it in for the left side of the equation, and then you're bringing down the right hand side of the equation. So now if you wanted to solve this, notice your variable is t, which is going to represent the time that they were underwater. So I could divide both sides by negative 15, and I end up with negative divided by negative, means that my t is going to be a positive 3 minutes. So I know that when the diver is 3 minutes underwater, they will be at negative 45 feet. Next one then. So we're going to identify what the input value is here, the output value. We'll talk about what y-intercept is again, and the rate of change for each of these. So for the first one, I'm going to just kind of lay this out here, input and output. So a backyard pool contains 500 gallons of water. It is filled with additional water at a rate of 6 gallons per minute. Here's my function, f of t equals 6 times t plus the 500, which represents the volume of water. So this is really the amount of water that's in the pool as it's being filled. So let's take a second and talk about what this equation actually means, this function. So f of t is going to represent my total output, and that's going to be how much water is in the pool. T is the variable we're using to represent the time that the person is filling the pool. So I know that if I substitute a value in for t, it's going to give me how much water is actually in the pool. So my input value is going to be time, and that's going to be measured in minutes. The person is filling the pool for however many minutes, and I know that it's going at a rate of 6 gallons per minute. My output value is going to be that volume or amount of water, and that's going to be measured in gallons. So the next thing I want to do is talk about that rate of change, which we did in section 2.1. Rate of change is what is going to compare your output unit to your input unit. So it's going to be something gallons per minute. And again, notice the order of that. It's always comparing output to input. So 6 in this case represents the amount of gallons per minute. So 6 is my rate of change. The last thing I want to talk about is what my y-intercept is. So y-intercept, it's kind of one of those things we just call a starting value, but I don't want to just say starting value. I want you to understand, and I'm going to go to the last problem for this, that when we say starting value, what we're saying is when your independent value is 0, what is your dependent value? This will be your y-intercept. So in the last problem, after 0 minutes, the diver was at 0 feet, and notice it's because they were diving from the surface. So in this example, the person is filling up the pool. If I substitute 0 in for t, if they're not even filling 0 minutes, 6 times 0 is 0, but we still have the 500 here. And that's because my y-intercept is 500, which means that the pool, before we even started filling it, the pool already contained 500 gallons of water. So the 500 gallons is your y-intercept because I know that after 0 minutes, the pool already contained 500 gallons. So when your independent value is 0, or when your input value is 0, your output value will be your y-intercept. So in this case, it's the 500. In the next problem, kind of like the one that we just did, a submarine is diving from the surface of the water at a rate of 17 feet per minute. And here's our negative again. The function f of t equals negative 17 times t represents the depth of the submarine as it dives. So it's negative because we're going under the surface of the water, so below sea level, which would be a negative number. My input value is how long the submarine is going to be underwater, so that's going to be time. And I can grab my unit from over here. It's time measured in minutes. And then my output value. So if they're down there for 1 minute, 2 minutes, 3 minutes, 3 minutes, what's going to depend on that? And that would be the total depth. So the depth, which we can see up again from here, the 17 is in feet. So it's feet per minute. So that's going to be my next thing, will be my rate of change. So rate of change in this case, since they're diving underwater, it's negative 17. And notice we are comparing our output unit to the input unit. So it's 17 feet per minute. And the last part, very important, the y-intercept. Again, sometimes you think about it like it's a starting value, but I want you to think about when time is 0. So after 0 minutes of diving, 0 times negative 17 is 0. So what that means is they are at 0 feet. Another thing you can look at is the fact that the submarine is going from the surface of the water at a rate of 17 feet per minute. So they're already at the surface. So their starting value is at 0 feet. Next one, I'm going to kind of switch this up a little bit. With this problem, I'm going to give you a function, and I'm going to give you an output value, and we're going to trace back to find what the input value is. So the part that I'm going to change on this is actually, instead of using 450, I'm going to use 1200. And what we're going to do is, I'm giving you that f of x equals 1200 is going to be my output value. And what we're going to do is find where that is on the left side. We're going to trace back to find the intersection point of our function in that, and then that will give me the corresponding x value. So notice I'm giving you the f of x part as being 1200. So what I want to do is go to where 1200 is on my y-axis, and we're going to trace all the way over to where we find our function. Notice I get a nice pretty intersection here. I'm going to trace that down, and at 6 we are at 1200. So what I'm going to do is say when x equals 6, y equal, or I'm going to say f of x. So I'm not going to say y, I'm going to say f of x equals 1200. So when I'm giving you the f of x value, I'm really giving you that y value. I'm giving you what is on the y-axis. So notice we found where 1200 was, and we worked our way backwards to figure out what corresponding x value would give me this coordinate. So notice that coordinate is 6, 1200. So the x value is the 6, the y value is the 1200. And again, kind of relating the graph to the equation, your input value would be your x value. So if I substitute 6 in for x, if you took negative 200 times 6, you would get negative 1200. And if you add 2400, you would end up with 1200. So when f of x equals 6, or I'm sorry, when x equals 6, f of x equals 1200. And one last thing that I kind of wanted to point out with this problem too, notice f of x, I'm going to just copy down my equation here. I want to talk about what y-intercept was again. Y-intercept was whenever x is 0. When x is 0, what is my y value? So notice when x is 0, this quantity goes away and I would be left with 2400. Well, notice where that is on our graph. When our x value is 0, so the coordinate here, when x is 0, your y value is 2400. So notice, y-intercept means where the function crosses the y-axis. So you can visually see here on the graph, but you can also go back to the equation and see the same thing by looking at 2400 whenever x is 0. So then I have my last problems. What we're going to do is substitute for these and solve for x to determine the exact value. So this is going to be kind of what we did on these last problems, except we're not going to use a graph. We're going to use an equation. So f of x equals negative 2x plus 5 when f of x equals negative 7. So what I want to do is find what x value it is. So when f of x equals negative 7, so what I'm going to do is substitute negative 7 in for the entire left side. Notice you're not just putting it in for x. It says f of x equals negative 7. So replace the whole left side with negative 7 and just bring down the right hand side of the equation. So what we're really doing is trying to solve for x here. So in order to do that, what I'm going to do is subtract 5 first. So that's going to go away. Negative 7 minus 5 is negative 12. Bring down the negative 2x. And now notice that negative 2 is being multiplied by x. So if I want to get x by itself, you need to do the inverse of multiplication. So that's how I'm going to divide. And then negative 12 divided by negative 2 is positive 6. So I know that when x equals 6, my f of x is negative 7. And how can we check this work? Substitute it right back in. If you substitute 6 in for x, negative 2 times 6 is negative 12, and negative 12 plus 5 would give me negative 7. So it wants us to write this out as an intersection point. So I know that when x is 6, f of x is negative 7. So again, another way that we can kind of say that is that when x is 6, your y value would be negative 7. So instead of using y, we're using function notation, which is why we say f of x. And then in this one, same exact thing. I'm going to substitute the 8 in for the left side of the equation, in for f of x. I get 4x minus 7. So in order to solve this, what we're going to do is add 7 to both sides first. 8 plus 7 is 15. And 15 equals 4x. So what you are going to do, just like we did in the last problem, to get rid of the multiplication here, I need to use the inverse, which is division. So 15 divided by 4, and you can go to your calculator on this, it's going to be 3.75. So we can still express this as a coordinate, even though it's kind of an ugly number. It's a decimal, that's okay. 3.75 is our x coordinate, and our f of x was the 8. So just to recap everything we've done in this lesson then, we filled in a table with input and output, independent and dependent quantities. I solved the equation here, which is what we ended up just doing at the very end of the video. We talked about what the y-intercept was and rate of change. We used a graph to figure out where our input value was when I gave you an output value. And then we also used an equation to figure out what an intersection point was when I gave you an output value.